So this is 3 point, is it 3.5? Yeah, 3.5, number 13. So what's the answer? Do you have the answer? Yeah, you got to be checking. Everyone has to be checking their answers, right? You don't want to do homework and not know if you're right or not. So especially you don't want to do 13 problems and not know if you're right or wrong. You just wasted 2 hours of time, right? I'm not quite sure, but either way, you should be checking your work, like just on the test, you're going to check your work, right? So, and I gave you odd problem solutions, right? Am I right? Your answer looks really close to being right. I can't tell for sure. I'd have to do the problem, but I want to look at the answer first, okay? So in Blackboard, in our class, in announcements, I think it's like the second announcement or something. Third announcement. Nope. It's here somewhere. Here we go. Odd solutions. And it's chapter 3, correct? Sorry. Oh, this is, I went too far. Sorry. Here we go. 3.6, 3.5, number 13. Yeah, that's what you have. Nice. You want me to do it anyway?
Yeah.
Okay. So I'm doing a derivative of both sides, right? I think the easiest way for me to write that is to say prime on the left and prime on the right. Okay? Uh, on the left-hand side, I need a chain rule. So that's e to the x over y times the derivative of x over y. And on the right side, it's simple. It's 1 minus y prime. Everyone okay with that? Everyone okay there? So all I have to do is that one little piece with the prime on it with the quotient rule and implicit. First function is x, derivative is 1. Second function is y, derivative is y prime. And because I'm doing the quotient rule, I need a y squared. So I get y minus xy prime over y squared times e to the x over y equals 1 minus y prime. And if you remember here, I am trying to isolate my y prime terms, right? So I'm going to distribute here, right? I'm going to distribute this e to the x over y squared. So I get y e to the x over y squared minus xy prime e to the x over y squared equals 1 minus y prime. Again, the way I do my algebra is the way I do my algebra. You do it the way you do it, right? You've already passed algebra. You should have already passed pre-calculus and trigonometry, so that your algebra is pretty much set. I want to get all my y prime terms on one side. I'll choose to move them to the left. And I'll move all my other terms to the right. And it looks like I can cancel a y there. I'm factoring out my y prime on the left. And then dividing by that entire factor. I see that I have an LCD of y squared. What else could I use there? Instead of y squared, what could I use? Y cubed. You can just take all the interior denominators and multiply them together. You just got to do a little bit more work. Say again? Yeah, you're not copying it. You already did it right. Okay. So now I'm clearing fractions, and I get y squared minus y e to the x over y. And then downstairs I get y squared minus x e to the x over y. And then of course I can factor. If possible, I can factor. Sorry, that's a y. That's a y squared. And the only thing I can factor is a y out of the top. So not that important. There is one more thing I can do, and that's if you remember e to the x over y is x minus y. I could replace, right? I could replace all of the e to the x over y's as an x minus y. Anything else? So good work, Mike. Anything else you want me to do in the homework or past exams? So I got my outline here. I am collecting homework, please. Let me have the homework. Arsama, I got yours, thank you. What's the name of this printer? I don't know. But if you log on to there and go to print, you'll see the name of it. It's like some horrible 18-character long. So for Thursday, music if you want, right? As long as no one else can hear it. One page front and back printed. Cannot be on a tablet, cannot be on a computer. Calculator is fine, Desmos is fine, but you must be logged into our computer, right? If you send me, I don't want to print you formula sheets on Thursday because I might forget and then you're out of luck. But so if you send me something before class on Wednesday, I can print for you. Homework, guys. Cyril, Natnal, and Evan. Homework, please. No homework? You got it? Evan? Homework? No? All right, let's do the new stuff. Got no questions, that's fine. You do have tomorrow to ask questions, Wednesday to ask questions. Thursday, we're just taking the test. You don't need to bring notes with you. You don't have to be scrambling through and looking at stuff. You should have your formula sheet, whatever you're writing with, your calculator if you want. and be ready to take the test first thing. That's all we're doing. So again, tomorrow we're leaving at 2, but at 2 the Math Learning Center is open. And then Thursday we're leaving at 2:30. No matter when you come in, if you come in at 1 o'clock, you only have an hour and a half to do the test. Okay? All right, here we go. So today, because you're not asking many questions, I should easily be able to go through section 4.2 and section 4, half of section 4.3. If I have more time, I will take that time to keep going in 4.3. I will do all of chapter 4 this week. Okay? So what I would do as a student is make sure I'm ready for the test first before you're doing any, thank you, before you're doing any chapter 4 material, right? And then after Thursday, you should be get caught up on all of the chapter 4 homework, reading, practice, etc. Okay? So this is 4.2, and it's about the absolute min and max of a function. Absolute min and max of a function. So of course, if I looked at something like f of x equals x cubed, right? There's clearly no max and no min. Something like e to the minus x squared has a max but no min. Right? The min gets really, really close to what? 0, right? It gets really close to 0, but that never actually gets there, right? So the main thing is we have a theorem here that we're going to kind of instinctively think is true, and I can show you some counterexamples, right? But we're going to apply that theorem in this chapter, and the theorem is, I think I need to give you a second here though. I am recording. So here's our theorem. If f is continuous on a closed interval AB, then f must have an absolute max and an absolute min. Special note, the max and min will happen at 3 possible locations, or 2 possible locations. The absolute min or max will occur on the endpoints or the critical values on the critical values of f prime. Sorry, or at. That's fine, on the critical values of f prime. And what are the critical values? When the derivative is 0 or the derivative is undefined, that translates to when the numerator of the derivative is 0 or the denominator of the derivative is 0. Of course, if I have a 0 in the numerator, what kind of tangent line am I talking about? Horizontal, right? And if f prime does not exist, there's a vertical tangent line. One thing that happens when you start doing applications is there's a lot more writing. So you just got to be patient with me. Make sure you put all of the writing for your second exam. Put all of the outline that I'm giving you, or better yet, I'll call it step by step. Put the step by step directions on your formula sheet. I haven't given you any step by steps yet, but I'll call it step by step. Numerator. So I told you I'm not going to prove this theorem, but it should kind of make sense. But let's look at some counterexamples, right? So what could I destroy here in this theorem is I could take out the continuity. I could take out the closed interval. And in both those cases, if I do that, you'll see I can give you an example of it not having an absolute min or max. In fact, I already did it, right? I already gave you two examples. Yep, 1 second. This x cubed is continuous, but it's not a closed interval. Same thing with e to the x squared, continuous but not a closed interval. Vertical tangent line. So let's look at a step by step We ready? Yeah? And it won't make a lot of sense till we do a problem, but we'll do a bunch today. I guess we want to make sure the theorem applies. And how we do that, make sure it's continuous and make sure it's a closed interval, right? So that should be obvious. We want to look at the graph. And of course, we're going to use our restrictions in the graph with Desmos, right? We want to find the heights, find f of A and f of B. So we're going to find the height at the endpoints, right? We want to find f prime and the critical values. C such that A is less than C is less than B. I don't care about critical values outside of my closed interval, then I don't care about my critical values on the endpoints. Is that Peter? Yeah. Holy cow, where the hell you been? Test is Thursday. Test is Thursday.
Okay. I've had a lot of trouble with my apartment. There's been like
yeah. It'll really drain you, huh? Sorry to hear that. You got no choice.
Yeah, I know. I've been watching the video.
Okay, good. Find f of c. Make a conclusion. Unfortunately, that means you're going to write your summary of what happened in the problem, right? I am recording this already, Peter, as well. All right, let's do a couple of. Yep, no problem. I only had 1 cup of coffee today, so I don't know why it feels like I'm going too fast, but you gotta let me know. So lots of nice problems in the textbook here. In fact, I'll say to you in 4.2, I know that, I'll go right back to it. In 4.2, I like everything up until 59. Good, thanks. So in the homework, I like up to 59 odds, of course. And then, of course, looking at our homework, for homework 4, which is not due until week 5, okay? Not due until week 5. It's not, today is week, oh, yeah, you should do it for week 5, yes. So homework 4 starts in 4.2, and there's 4 problems in 4.2. Let's do a couple of example problems. Let's take a look at f of x equals x e to the minus x squared on, sorry, let's say negative 5 to 1. So, any problem with this thing being continuous or not? Is there any value that makes it undefined? No, right? I'm not dividing by anything, right? And e to the minus x squared can't be 0 at all anyway. So we want to look at this graph. So I'm going to Desmos. So are you. I'm going to take a look at my graph of this particular function. F of x equals x times e to the minus x squared. And I want to restrict my domain from negative 5 to 1. Let me make it negative 2 to 1, just so I get a little bit of a better visual. Absolute min and max. So it looks like no problem. And what's nice about using Desmos here is I can actually see the solutions. I can see that it has a max over here. Can you see my mouse moving there? Up on the screen? Yeah, so it looks like the highest point is here and the lowest point is here, right? But we still want to follow process, even though we know where our max is and our min is. We want to follow the process, right? Follow that step by step. So first thing is find f at negative 2. And of course you can find a decimal. Not that interesting to me, but it certainly can help you justify whether things are equal or not, right? So we want to plot that point in there to make sure. So I had the point -2, comma, -2 divided by e to the fourth. And of course, we should be able to verify that the endpoint on our graph is there, right? We want to find f of 1, so that's 1 times e to the minus 1 squared, or 1 over e. And again, I could find the decimal equivalent if I needed to. But you clearly know -2 over e to the fourth is negative, and 1 over e is positive. So at least that I can figure out whether it's a min or a max there, right? But I want to plot that point as well. 1 comma 1 divided by e. Oops. Nice. Now I want to find the derivative. Everybody okay? Yes, everybody okay? Nice. Say again, Mike? Oh, Peter? Yep. Nice, thanks. So we want to find our derivative, right? Factored, and then find our criticals. So I'm going to need a product rule. First function is x, derivative is 1. Second function is e to the minus x squared. Derivative is e to the minus x squared times a negative 2x. And we get our product rule with e to the minus x squared minus 2x squared e to the minus x squared. And notice I picked this one first because in a product rule I can. I'm just picking the positive one. If I have one factor positive, sorry, one term positive, one term negative, I'll pick the positive one first. So I can factor out an e to the minus x squared, and I get 1 minus 2x squared as the other factor. Everyone okay there? So you can see this is not going to hurt us at all. We're just going to be practicing more derivatives, and we need to be able to do that for exam 1. I'm sorry? Okay. So we found the value of the function at our endpoints. We found the derivative. Let's find the criticals, right? So f prime of x is equal to 0 implies 1 minus 2x squared equals 0, or what? X squared equals 1/2, or x equals plus or minus 1 over square root of 2, or rad 2 over 2, right? So the process is I'm going to find my highest point or my lowest point at the endpoints or when the derivative is 0. It's pretty clear when I look at this graph, I've got a high point here and the derivative will be 0 because I'll have a horizontal tangent, and I have a low point here. Again, the derivative will be 0 because I have a horizontal tangent again. Or undefined. Or undefined. What's that?
And what would you look for that?
It would show up as a critical. Remember, our critical values is when the derivative is equal to 0 or the derivative is undefined, meaning when the numerator of the derivative is 0 or the denominator of the derivative is 0. I don't have a denominator for this derivative, right? Or you could think of e to the x squared as the denominator, but that's never 0. So once I found my critical values of f prime, I want to make sure that they're in my open interval, and they are, right? -2 is less than plus or minus rad 2 over 2, which is less than 1. That's true. And again, if you don't believe me, check your, right? Check your, with decimals if you don't believe me. So we want to find the value now of the function at those criticals. I think I can do them both. F at plus or minus 1 over square root of 2 is plus or minus 1 over square root of 2 e to the minus plus or minus 1 over square root of 2 squared. And that is e to the minus 1/2. So it's plus or minus rad 2 over 2 divided by the square root of e. So what is that? I guess it could be a little bit prettier, but that's fine. And I'm just plugging in there, right? I'm just plugging in to the function there, right? Yes? Daniel? Well, that would make it 0. I already know it's a critical of the derivative. So, but remember what I'm trying to do here, my ultimate goal is to find the highest point on the function f. So I have to find the height of the function at the criticals. Let me put those 2 points in, right? And again, you don't have to copy me. You can be doing this evaluation yourself, right? You just plug the values into the function. You make sure you understand what I'm doing, right? If you're just copying me and not doing it yourself, you're not going to understand as well. So let me put those values in. The first one is negative square root of 2 over 2, comma, negative square root of 2 over 2. I'm sorry, what did I have? I had 1/2 times the square root of 2 over e, right? Nice. And do you see that that's my lowest value? You see it's my lowest point on the curve? Somebody just tell me yes. Thank you. How I got the point? But do you know how I got the critical? So the critical came from here. I found my derivative, and I set it equal to 0. This can't be equal to 0, so it has to be this that's giving me a 0. No. Whatever I give you, let things happen. Don't expect the same thing to happen every time. Just do the process. Question. So the first y value, remember I have to do both, right? Sorry, I have to put in both, plus square root of 2 over 2 and negative, so I just picked the negative one first, doesn't matter. So, got to do them both.
But the positive is not on the graph, so you just
the positive one is on the graph, I just haven't done it yet, it's over here, right? So let me go back to Natnal first here. So I find the critical value, find when f prime is 0, and I got it, plus or minus square root of 2 over 2. And now I plug that into the function. Plug those criticals in the open interval to the function. So let me put the other one in there. And let me cheat, right? Say again? Yep, let me put this in first. So I'm putting in the positive rad 2 over 2, and I get this answer. Oops. And you can see there's my max value. When I take a square root. When you take a square root, you must do positive and negative root. Say again? Yeah. Yeah, so x squared equals 1/2 is what I got from here. Right? And then I took a square root, so I get x equals plus or minus 1 over rad 2, and that's the same as plus or minus rad 2 over 2. Remember in trig class when you rationalized? You remember in trig class when you rationalized? Just lie to me and say yes. Thank you.
So the plus or minus half times root 2, what is?
That's the y value. That's the height of the
How do
function.
you know that's plus or minus?
They actually go with each other. The plus goes with the plus. The minus goes with the minus.
Is there a way that they're the opposite?
They could be.
You would only know by plugging.
Right, plugging in, yeah. But you also remember you're having your little cheater. I like to say that I'm cheating all the time in chapter 4 here because I'm going to look at the graph. Every time I give you a function, let's look at the function, right? And then we're going to use the calculus to verify the things that we see. So we clearly see that that black point is the highest point on the curve and that purple point is the lowest point on the curve. And then I just did the calculus to find where those points were. Yep. Yes. Yes. Line 3. They're same thing. Plus or minus 1 over square root 2 is the same as plus or minus rad 2 over 2. And I'll remind you, no, I'm going to remind you from pre-cal, we would rationalize with rad 2 over itself, and I get a rad 2 over rad 4, which is rad 2 over 2. Yeah, so then I take my critical values and plug them back in the function. Yeah. Notice that I'm taking critical values and plugging them back in the function to find the point on the curve. I'm going to do the same thing all through this chapter. So I got to get a derivative to find criticals, then take the criticals of the first derivative, plug them back in the function to find the points on the curve. Same thing with second derivative. I'm going to find the second derivative, I'm going to find the criticals of the second derivative, and I'm going to plug them back into the function to find the points on the curve.
Making sure that this continues at AB, is that just plotting it?
Yeah, you could obviously see it from the curve, but you also know that where you're going to get something discontinuous is when you get an undefined point, right? So if we look at all of our answers, right? If we go decimals, and I'll do that just for the sake of pretending I don't already know the answer. What was my first height? My very first height was -2 divided by e to the 4th. So that was about negative 0.037. We also got a 1 over e. 1 divided by e. That's about 0.368. And then our plus or minus 1/2 square root of 2 over e is approximately plus or minus 4.29. Sorry, 0.429. No, I don't like the decimals. I had a friend named Dewey, and he drove me crazy, so I don't like decimals. So it's pretty clear, even and from the graph, I can make my conclusion now. Sorry, 1 over square root of 2, comma, 1/2 square root of 2 over e is the max. And the negative version of those is the min. Yes, question? To the function.
The original function, right?
Yes.
Up to the second part, the square root of 2 over 2 2
Yeah. Keep, change, flip, I did.
Sorry, function part.
Yeah, e to the minus 1/2 is 1 over square root of e. E to the minus 1/2. E to the minus 1/2 is 1 over e to the half is 1 over square root of e. I don't understand what you're saying. So you understand? I'm just taking the critical values and plugging them in there, right? Okay. Yeah. So you just don't like my arithmetic, I guess. Yes, I did. Yes. I'm trying to make it look as pretty as I can. Yes. 2 over e, square root of 2 over e. Plus or minus, right? So look at this step by step again, okay? Make sure I agree. It's continuous, it's a closed interval. And graph it, right? You can almost do those simultaneously, right? Find the height of the graph at the endpoints. Plug in the left endpoint, plug in the right endpoint. Find the derivative. Find the critical values of the derivative. I only care about ones that are within the bounds of the endpoints. And then I find the height of the function at those points. And then decide which one is my highest point, which one is my lowest point. Can I do what? Yeah. Yep. Critical, well, it's either endpoints or critical values. Let's do an easier one, so at least it'll make you a little more comfortable, and then I'll give you one that I put on every exam for as long as I've given exams. Let's do an easier one. Let's take f of x as x squared on minus 1 to 2. We certainly don't need Desmos for this. And I certainly can see that this part is my maximum. Right? We agree? That's the highest part. And this point is my minimum. That's the lowest point. Everyone agree with me? Does anyone agree with me? So we're supposed to find f of -1. That's -1 squared, that's 1. We're supposed to find f of 2. That's 2 squared, that's 4. So clearly 4 is a potential maximum. 1 is not. You agree with that? 4 is bigger than 1, so I know it's higher. But I already know the answer from the graph. I have to find f prime, which is the derivative of x squared, which is 2x. I have to find the critical value. That's when 2x equals 0. So what? X equals 0. And now I have to make sure that 0 is between my endpoints. Is that true? Yes. So now I find f of 0, which is 0 squared, which is 0. So I'm about to make my conclusion, and I notice that I got a height of 1, a height of 4, and a height of 0. Which one is the highest one? 4. So 2 comma 4 is the absolute max. And 0 comma 0 is the absolute min. Easy, right? Why? All I have to do for critical values is set the derivative equal to 0. There's no denominator here. But if there was a numerator and a denominator, I set the numerator equal to 0, I set the denominator equal to 0. One more time? Yeah, well, you're learning something that was done in 1814, okay? When they did have calculators, they didn't have batteries, right? But now that we have the computers and the calculators, we can see the calculus, but we want to verify what we see with the calculus. So no, don't skip steps. Let's do another. Yep. I'm sorry, my x value tells me where to plug into the function to find the height. The height is telling me what's the biggest or the smallest. Highest up in the air, lowest in the air. So y values. Y values are heights, right? So the y value is telling me the height of the function. The x value is telling me where on the function, left or right. Yes, it was. X endpoints. Are we talking about endpoints or criticals? Yeah, because 4 is the highest output I got. What? The 2 is the endpoints. Oh my! Listen. I know it's new, but there's a step-by-step. Find f of the left endpoint, the height of the left endpoint, find the height of the right endpoint. Find the critical, find the derivative, find the criticals, find the heights of those criticals. Whatever height I got from endpoints or criticals is the max. Whatever one's the biggest, whatever one's the smallest is the min. Yes, question? Yes. Yes.
What is that? What's zero?
The height. Well, you can see it here on my graph, right? Oops, sorry, on my graph on my picture. This is 1, negative 1, 1. This is 0, 0. This is 2, 4, right? So obviously that green is the highest, and notice the y value there is 4. My other y values were 1 and 0, right? The other y values were 1 and 0. Which one is the smallest? That's the min.
But how do you, so plugging in 0 to back into the function gives me the variable.
Not necessarily. After I find the height at the criticals and at the endpoints, I decide which one is the highest.
How many critical values?
Could be many.
This one is 1.
Correct.
So plug in 9 in at 1 number.
Correct.
And in this case, it's the minimum, right?
Correct.
So then
But it won't always happen that way.
how do you get the maximum?
Same way. You're now. So once I plugged into the endpoints and I plugged in my criticals, I'm going to decide which one is the highest, which one is the lowest. So when I plugged in 1, negative 1, I got a height of 1. When I plugged in 2, I got a height of 4. When I plugged in 0, I got a height of 0. Which one is the biggest? The 4. That's the max.
So you use all three of these numbers to determine what the max
Exactly.
y value is.
Correct.
And then how do you find the x? Well, we'll know by the.
Endpoints and the critical values.
Okay, and there could be 3 or there could be 4.
There could be any number. Let things happen. Let things happen. Can't expect when you're given a function, you got to discover what's going to happen with it with the calculus.
If there's a 4 when it says a is less than c is less than b.
That's important because sometimes my criticals will happen on the endpoints or outside of the endpoints, and I don't care about them in that case.
It's not giving you another option.
Exactly.
Well,
Yes.
critical value is 1 f prime of x, right?
Or,
F prime.
nope, f prime of x is undefined.
Okay.
All right, let's do a tough one. Let's say f of x is x square roots of 1 minus x on negative 2 and 0, from negative 2 to 0. I'm sorry, negative 2 to 1 again. I don't want to confuse you by using those same pieces, so I'll make it negative 3 to 1. I swear, I promise I won't change it again. Clearly there's trouble with this function, right? What kind of numbers will give me trouble? Negative numbers in the radical, so anything bigger than 1 would be trouble, right? We agree with that? So if I plugged a 2 into here, I'd be in trouble. It's not in the domain, right? Let's graph it. So clearly you can see the lowest point on an endpoint, am I right? And the highest point where there's a horizontal tangent. Do you see that? Say it again? Oh yeah, I changed it to negative 3. Thank you. Still, right? Yep. Everyone okay? What's the first thing on my list? Well, I did that. What's the next thing on my list? Find the heights at the endpoints. Yes? Everybody with me? You're not copying me, you're plugging in yourself. So you're finding f of negative 3. And I get a height of negative 6. Anybody else get that height? I also want to find f of 1, the other endpoint. That's 1 times square root of 1 minus 1. That's 0. So 0 is a possible max at this point. Negative 6 is the possible min, right? Because negative 6 is the smallest, right? The lowest height. Good, I have to find, everyone okay with the other endpoint? Not, no, yes? Okay, find the derivative. I'm not doing it. Not letting you copy me. Anybody get it? What's that? Square root of, where are you? I'm at, it doesn't matter if in product rule, I just picked the positive one first. Yeah. Anybody get the derivative? Say? But you got exactly this box. Yep, that's what I want. You have to have it completely factored as a single fraction. Now I have to find the criticals. Anybody need me to talk about the derivative? Or any line there of me finding the derivative? I'm assuming step 3 is where you might get confused, but I'm just getting an LCD, right? Everyone okay with the derivative? Yeah, I want to get, remember, I'm trying to always get my derivative as a single fraction completely factored. Yeah, for the next step now, I want to find when f prime of x equals 0, and that is when I get 2 minus 3x equals 0. That is when x equals what, 2/3? That's a critical value. Is that between my endpoints? Yes. Question? Yeah. On line 3 in black is from my product rule, right? And then I see I need an LCD. The denominator is this, so I use that over itself to multiply by 1. Yep. I also need f prime of x does not exist, which implies 2 square roots of 1 minus x equals 0, which implies x equals 1. But if x equals 1 is my critical, I already know the height because it's the endpoint, so I can ignore it. I don't have to check the height at 1 again. I already know the height at 1. Do you hear me up? You hear that? You catch that subtlety? I found another critical, but it was the same as an endpoint. So I don't need to find the height again. Don't bother with it. I know the height at 1 already. But the one that I got from the denominator was useless. So now I have to find f of 2/3. Yes?
Let's take a fraction, you only zero for the one look for the zero numerator.
Yep, those are horizontal tangents. And the 0 in the denominator is a vertical tangent. So f of 2/3. So I get what? 2/3 times the square root of 1 minus 2/3. That's 2/3 times the square root of 1/3. I get rad 3 over 3. I'm sorry. Did I do that wrong? Yes, I did. Two square roots of 3 over 9. So I want to check that point. I had an x value of 2/3. I had a y value of 2 square roots of 3, all divided by 9. Yes, there's my I point. I had endpoints of -3, comma, what, -6, was it? Yeah, and I had 1, 0. What point is the highest point? What color? What's the lowest point? There you go. You know how to do it. It's that easy. Conclusion. 2/3, comma, 2 square roots of 3 over 9 is the absolute max. And -3, comma, -6 is the absolute min. Easy, right? I'm listening. Let's do one with the trig and then take a little break, okay? Yeah, question? The first one we did. So, this tough one. Yeah. It can't happen. You got to let things happen. Yeah. Because they were in between my, if you remember me, once I got my decimals, I checked, right? Where did I check my decimals? I did it somewhere. Oh yeah, here. Right? What's that? Yes, exactly. Because, well, outside of the endpoints, I'm not using it at all. And the endpoints, I already checked the heights, so I don't need to check them again. First thing I do is check the heights of the endpoints. So if a critical is an endpoint, you don't have to find that height again. You already know it. Let's do a trig one. Oh, where is my textbook? There it is. Uh, 53. I'm going to write it here, okay? So this is 4.2, number 53. And I've got f of x is equal to 2 times the cos of x. Sorry? Plus sine of 2x on 0 to pi over 2. Good, let's graph it. Woohoo, look at that. Funky. Huh. Obvious, right? Where the max is, yes? Obvious where the min is. But we're doing the calculus to verify what we see. That's what I want from this whole chapter, is that you're going to know what you're looking for, but you're going to use calculus to show me that you understand how to get it, right? Okay, what's first? Endpoints. Yep, endpoints. So 2 times cos of 0 plus sine of 2 times 0. That's 2 times 1 plus sine of 0. That's 2 plus 0. That's 2. F of pi over 2 is 2 times cos of pi over 2 plus sine of 2 times pi over 2, which is 2 times 0 plus sine of pi. 0 plus 0 is 0. I like at this point to plug in the points into my into my graph. So I had 0, 2, and I had pi over 2, comma 0. obvious from the graph, right? Obvious from the graph, the blue point is the lowest point on my curve. Okay, find me the derivative. Anybody get there? Nice. This one is not factored, so it's going to give me a little bit of trouble when I'm trying to find the critical values. And I'm going to need an identity here, right? But of course, we'll have our trig identities on our formula sheet. The question is, which one do you want to use? And in this case, we're going to use cos of 2x is 1 minus 2 sine squared x. Yeah, I got to find the critical values, right? Yes, absolutely. So let me start that again. So find f prime of x equal to 0. So I want to find 2 cos 2x minus 2 sine x equals 0. And of course, I can divide by 2, so I get cos of 2x minus sine x equals 0. And here's where I need the identity. Cos of 2x is 1 minus 2 sine squared x. So it looks like I get a quadratic. And whenever I'm solving a quadratic, I want my leading term to be positive. So I'm going to divide everything by negative 1. Everybody okay here? Again, I got to let things happen, okay? Let things happen. If I set it equal to 0 and I can't factor, I got to do something else, right? And I'm using quadratic formula. In this one, you can't. I mean, you could complete the square. Can't factor it out. Well, you've got a sine squared, a sine, and a number, right? So there's not a sign in each. That's the only thing you could possibly factor.
Tends to not.
Oh, yes, you could, yes, absolutely. Split the middle term, yes, yeah. Sorry, you're absolutely right. How'd we do? How many of us got the derivative? None of us got the derivative. Okay, one of us got the derivative. 1 out of 7 got the derivative. You got the derivative. Okay, 2 out of 7 got the derivative. Mike, you didn't get the derivative?
No.
Why?
I thought it was equal. It was negative 2 sine x plus 2 cosine.
It so it is though. But that's right, that's what I got. Derivative of 2 times the cosine is negative 2 times the sine.
Yeah, I've been trying to get to 0.
Yeah, the 0, so the 0, I gave you the hint. We set it equal to 0, right? We set our derivative equal to 0. We divided by 2. We used an identity for cos of 2x and realized that we had a quadratic. So we set the quadratic equal to 0. I used the quadratic formula. You could factor the quadratic if you want. I got 2 answers from the quadratic formula, -1 and +1/2. So I know that means sine of x is -1. That happens at pi, but that's outside my interval. And I know sine of x is 1/2 happens at pi over 6. That's inside my interval. So now all I have to do is plug in pi over 6 to f.
Sine x equals -1.
Yes. When does sine equal negative? Oh, not at pi. Sorry, it's at 3 pi over 2. Sorry, still not in the interval, right? And I get 3 square roots of 3 over 2. Yeah, we okay? How we doing? What's hard about this? What's difficult about this? What's new about this? Nothing. Maybe finding the critical values is new, but not really. Right? That's why we've been factoring all our derivatives all along. Is the process complicated? Yes. Put the process down on your formula sheet. Step 1, step 2, step 3. Right? All right, go take 7 minutes. Come back at 1:45. Take a break.